Just a reminder, guys, for the quiz number 7, the only issue in this problem how to calculate reactions. Until this moment, I'm still find student cannot calculate reactions. Doesn't make sense to me. Just a reminder, for this beam, we have hinge at A, so we have two reactions, YA and XA. D is a roller, so we have one reaction, YD. Guys, before starting to apply equilibrium equation, we have something we need to modify it. We need to adjust it. Uniform distributed load. Do you remember that in module number 5? If you have uniform distributed load, so I'm gonna assume we have equivalent value here. How much? 15 times 1 meter equal 15 kilonewton. How much? 15, the given distributed load value, 15 kilonewton per meter, time the total length, which is 1 meter. Where at the midpoint of this distance. That means this distance will be 0.5 and this distance will be 0.5. That's right? That's right. Please, if you still have issue with reactions, please go back to the recorded videos to remember how we can calculate reactions. The coming exam focus mainly. The first step in any problem, you have to calculate reactions. Okay, go ahead and apply the equilibrium equation. First one, summation f of x equals 0. The only force in x direction is XA, will be 0. Second one, summation f of y equals 0. What do you have in y direction? We have positive YA, we have positive YD, and we have negative 8, negative 8, negative 15. I have a good question. Which 15 you are talking about? This one or this one? No, I'm talking about this one. Yeah, I know the same value, but not the same meaning. They are not the same meaning. I'm talking about this 15, this equivalent force equals 0. If you would like to simplify this equation, YA plus YD equal 31. Third equilibrium equation, summation moment at any point equals 0. I recommend to take moment at A, and I'm gonna assume this direction is positive. Let's start. Taking a moment at A, XA times 0, YA times 0. We don't have distance. What is the next? I'm here. What is the next? 8 times 1 plus 20. We have concentrated moment at this location. Moment does not need distance. So I will not multiply 20 by any. Keep going. Plus 8 times the second 8 times distance 2. Keep going. Minus YD. Please go step by step to try. Don't try to forget any. So I'm trying to go step by step. The first one is 8. The second one is 20. The third one is 8. The fourth one is YD. YD time what? The total distance 3. Keep going. The next one 15. My question is, which 15 you are talking about? This value or this value? No, I'm talking about this value. The equivalent load, this one. 15. Time what distance? Distance between this location and A. 3.5. It's not 4. 3.5. You are done? Yes. Okay. This equation equals 0. This term will be cancelled. This term will be cancelled. The only unknown in this equation is YD. It will be 32 something, I believe. I cannot remember the number, but anyway, 32 kilonewton. If you go back with YD in this equation, I can figure out the value of YA. It will be a value 1.67, something like this. And probably negative. Negative means wrong assumption. I'm sorry, what you mean by wrong assumption? Yeah, you assumed YA 2 up. No, the correct direction for YA will be down. That's it. If you set up your reaction correctly, the second step, make your cut. Decide this side you are going to use or this side. Guys, when you are doing your cut, please, because I will assume, I'm gonna assume you are cheating. When you are doing cut, please draw the part you are talking about. I did cut here at E. I have reaction here, YD. I have distributed load with equivalent value 15. At the cut, I have normal, which is tension. I have shear, would like to rotate this part clockwise. I have moment, would like to make this bar to smile. Then I'm gonna apply summation f of x equals 0, summation f of y equals 0, summation moment at the cut equals 0 for this part only. Also, many students, they are not few, many students did not draw this part. They are talking about this equation and the final answer, and I know they are cheating. But I cannot prove this. Please, during the solution, please draw your free body diagram. This part, apply your equilibrium equation. That means you are calculating based on your drawing, based on your assumptions, not just cheating. And I have some students, and I would like to thank them very much because they deserve more than A in this course. I believe if I have more than A, I will give them this score. Anyway, let's go back to our examples. But before continue, do you have any question? Guys, do you have any question? Yeah, probably the student attending this live meeting does not, because the student who did these mistakes are not here right now. Okay, we have a beam, and this beam with fixed support at A. A is a fixed. Please go ahead and draw axial force diagram, shear force diagram, bending moment diagrams. Regardless, what is the required? in this problem, first step, we need to figure out reactions. This is a fixed. Do you remember? Fixed support. Fixed support. Yeah. We have three reactions. We have YA. We have XA. And we have MA. We have only one support. So I'm gonna assume we have three reactions: vertical, horizontal forces, and moment. We have three equilibrium equation. Let's do equilibrium equation to figure out reaction. Summation f of x equals 0. The only force in x direction is XA. Summation f of y equals 0. We have positive YA. We have negative 8. We have negative 3 equals 0. So I can figure out the value of YA, 11. Summation moment at any point equals 0. I'm gonna take moment at A and assume this direction is positive. Guys, be careful, please. If you are taking a moment at A, XA is a force with distance 0. YA is a force with a distance 0. MA is a moment, does not need distance. Does not need distance. But this moment will be negative. Why? Because I assumed clockwise is positive. So this one I assumed that MA counterclockwise, so it's negative. Keep walking. The next one will be 8 positive time 2. The next one will be 3 time 4. I am done? Yes, equals 0. This term will be cancelled. This term will be cancelled. The only unknown in this equation will be MA. The value of MA, 28? Yes, 28 positive. So this value, 28, this value equals 0, this value equal 11. Guys, if your reaction is positive, you assumed the correct direction for this moment, for this XA, for this YA. We learned this technique from trusses. If your calculations are positive, you assumed the correct direction. Next step. I'm gonna draw vertical lines at each force, at each change in the beam. And I'm gonna draw 3 cubes of this beam. One for normal force diagram, the second one shear force diagram, the third one bending moment diagram. Can you watch my steps? Can you watch my solution? Can you watch my organization? Please, your reaction on the left, the problem will be given in the exam on the right, so make sure the space below the beam is free to draw these diagrams. Some of you will attend the exam and they don't have any information or any knowledge about how to draw these diagrams. But guys, normal force diagram is nothing. Just one question, one simple question. Normal force diagram is a force parallel to this beam. Do you have any force parallel to this beam? Yes. XA 0. The normal force is 0. Very simple question. Very simple answer. 0. If you have a force, if you have a value for XA, okay, ask yourself the second question. This force pushing or pulling? If it's pushing, compression, negative. Pulling, tension, positive. That's it. Very easy. The second diagram, shear force diagram. It's a very simple game. Looks like a game for shear. If you have a force going up, go up. If you have a force going down, go down. But you have to start from what? Do you remember? Do you remember? You have to start from what? Guys, are you here? When you are starting to draw shear, you have to start from what? Which part? I'm gonna start from left. Thank you, Aaron. From left. Where is the left? Here is the left. I have YA going up. So I will go up. How much? 11. Then keep walking. Do you have anything here? No. Keep walking. You are at 11. The value is 11. Until you reach this point. I have 8. Going down. So I'm gonna go down. How much? 8. You are at 11. If you go down 8, I will reach to 3. Then keep walking. Do you have anything? No, keep walking. Until you reach, you are at 3. Until you reach the last destination. You have 3 kilonewton going down. Please go down. How much? 3. You are at 3. If you go down 3, I will reach to 0. You are good. Believe me. If you reach 0 at the end, you are good. Positive, positive. This is this diagram called shear force diagram. Any questions so far? Guys, any questions so far? Okay. Looks good. Let's do bending moment diagram. Ernest, do you have any question? Looks like you are writing something. Okay. Next step, I'm gonna draw bending moment diagram. But please go back to our rules for bending moment diagram. Just to remind you, if you have free end means it's an end without support, just free. Or you have simply supported end. Simply supported means you have hinge or you have roller. If you have one of these cases, your moment will be 0. We have another case. If you have fixed support at this end, we are talking about the left end, this end, you have fixed it. If you have fixed it, I think we are in this case right now because this end has a fixed. What should I do for moment? Very simple. Very simple. If you have fixed, I believe you will have 3 reactions. One of them will be moment. That's right. One of these reactions will be a moment. Yes, the value of moment here will be this reaction of moment. Positive or negative? Clockwise is positive. So counterclockwise will be negative. Okay? Let's do it. Do you have a moment here at this fixed? Yes. How much? 28. Clockwise or counterclockwise? Counterclockwise. It will be negative 28. Guys, this point is very important. This point is very important. I will do it one more time. Please, if you have a pencil and a piece of paper, please write these cases with me. We have two cases. First one, free end or simply supported. Guys, free end means we have a beam without any support. We don't have support at this end. Or this end is supported by hinge. Or this end supported by roller. We don't have any moment. So moment at this location will be 0. If you go back to the previous problem, at this location, we started with 0. Previous example, this is a hinge. We started with 0. Next example, this hinge, I will start with 0. This end is free end, I will start with 0. But this example, we have a fixed. So we are in the second case. If you have fixed support, this fixed support has a moment as a reaction. So the first value of moment will be this moment, positive or negative based on the direction. If this one counterclockwise, it will be negative. If this one clockwise, will be positive. Any question for this point? Any question for this point? Okay, Mitchell, you forget my talk. When I'm figuring out the reactions, I figured out the value of MA and I found MA equal positive 28. So the assumed direction for this moment is correct. So the direction of MA is counterclockwise. When I'm drawing the bending moment diagram, this direction is negative. So when you are figuring out the reaction, you have to decide which direction is correct. This your question, the answer will be in the reaction step. Okay, so reaction is a vital, is a big issue. You have to decide your reaction correctly, values and the direction, before starting to draw these diagrams. Okay, so at the beginning we have a moment. This moment counterclockwise, it will be -8. So I'm looking for what is the value here. Next value, what is the value here? Okay, we know. Assume this one is number 2 and this one is number 3. Can you tell me what is the value of M2? Yeah, M2 equal previous value -28 plus area of shear, the area of the shear force diagram between the 2 points. We have a positive diagram. The area is 11 times 2. So your final answer will be -6. So the value here will be -6. M3, value of moment at 3 equal previous value. M2, -6. Plus area of shear between the 2 points. We have here a positive diagram, this diagram, between this point and this point. The area is positive 3 times 2. Your final answer will be 0. Okay, that's fine. We have 0 here. Finally, please connect between this point and this point and this point with lines. And this diagram is negative. For your information, if you are looking for internal forces at this location, for point, for example, C, just go down and I can tell you the value of normal is 0. The value of shear, this value, 11. The value of moment, this value. So I can figure out the internal forces at any location using these diagrams. Okay? One more example. One more example. Let's do this example. The last one, example number 9. We have a beam. We have a trick here. So please pay attention. We have a beam and we are looking to draw axial force, shear force, and bending moment. Actually, I don't care about these diagrams until I figure out the reactions. Okay, go ahead and start with the reactions. I think we have here two reactions. YA and XA. Guys, do you think XA will be like this? Or like this? You can assume what you want. You can assume what you want. If you get a final answer positive, you assume the correct direction. If you get final answer negative, your direction is wrong. But today I have more experience with engineering mechanics. Do you think 20 will have two components, one like this and one like this? I don't care about the values right now, but I need to figure out the direction. I think the horizontal component will be to right. I believe the horizontal reaction here will be to the left to make a chromium. That makes sense? Guys, you can assume what you want. I don't care. You can assume what you want, but I would like to think a little bit. I would like to think, if you have a member or you have a beam and you have force here 10 kilonewton, I believe the reaction here will be opposite direction. Why? Because if you add this value plus this value, you can get 0. You can maintain equilibrium. Because the reaction is opposite to action. I'm talking about more experience about engineering mechanics. But the rule, you can assume what you want. Anyway, at B, we have a roller, so we have only one reaction, YB. Guys, we have We have something missed here, I believe. This distance is 4 meter. We have uniform distributed load. We have uniform distributed load. So we have equivalent here. How much? How much? How much? For the given distributed load value 4 times this distance 4. So you have 16 kilonewton. Where this side will be half distance, this side will be half distance, 2 and 2 meter. We have inclined force. Do you remember? First module, first week in this course, we have a force 20. You have angle? No. What do you have? I have right angle triangle. I'm looking for horizontal component and vertical component. Go ahead and select an angle. So I'm gonna assume my angle is here theta. This angle equal to this one in the right angle triangle. So your right angle triangle, here is the angle theta. This one is 4, this one is 3, this one will be 5. So sine theta equal 4 divide 5. Cosine theta equal 3 divide 5. This component, which is adjacent to the angle theta that you selected, will be 20 cosine. This one will be 20 sine. 20, what is the value of sine? 4/5. This component will be 16. What is the value of cosine? 3/5. So 20 times 3/5. This one will be 12. So the horizontal component is 12. The vertical component is 16. Kilonewton, kilonewton. This example, you have to make sure you are doing everything correctly for reactions. Guys, we have 2 reactions at A. We have 1 reaction at B. We have uniform distributed load, so I have to get the equivalent value. You have inclined force, so I have to get the 2 components, the horizontal and vertical component. Do you have any question? Do you have any question? If you still cannot understand these steps, please go back to the recorded videos for reactions. Recorded videos for module number 5, rigid body in equilibrium in 2D. I'm good right now. I am good. I set up everything. Please go ahead and apply equilibrium equation. Summation f of x equals 0. We have negative xa. I assumed it in the negative direction. We have positive 12 kilonewton. Anything else in the x direction? No. From this equation, I can say xa will be 12 kilonewton. Positive 12. Positive means you assume the correct direction, so this value will be 12 to left. Summation f of y equals 0. What do you have in y direction? We have ya, we have yb, we have negative 16, negative 20, negative 16. Guys, I have 16, I have 20, I have 16. Equals 0. I can simplify this equation, ya plus yb equal 52, I think. The third one, summation moment at any point equals 0. summation moment at any point. I'm gonna take moment at A. I'm gonna assume this direction is positive. Guys, please don't forget anything. Please don't forget any force. XA times 0. I am here at A. YA times 0. The next one, 16 time what? I'm talking about this 16. 16 time what? Please be careful. 16 time what? Time this little distance. Yes, how much? 2 meter. 2 meter. Thank you, Mitchell. 2 meter. The next one, 20. Time what? The total distance, 4. The next force, negative. YB time 8. Keep walking. We have 12. Time what? And we have 16 time what? Equal 0. Oh, I forget. Plus 150. We have concentrated moment at the end. Do you think this moment will need the distance? No. Guys, YB time 8. 12 and 16 and 150. 150 does not need distance because it's a moment. We don't need distance for this moment. 16, I believe 16 will be multiplied by 11. Anybody can tell me 12, this horizontal component will be multiplied by how much distance? I am here at A. What is the distance between A and this force to put it here? Any answer? What do you think? Thank you, Mitchell. Same question all the time. Same student answers the question. Nothing new. Guys, your force and your distance must be perpendicular. This force is a horizontal force. So your distance must be vertical. Do you have any vertical force? I'm sorry, any vertical distance in this beam? No, we don't have any vertical distance. You have a force here, and you have a point A here. The force and the distance must be perpendicular. So if time what distance you are talking about point A, we don't have the vertical distance. We don't have any vertical distance. We don't have any vertical distance. Anyway, so the only, this term will be cancelled, this one will be cancelled. The only unknown in this equation is YB. So the value of YB will be 16 times 2, 20 times 4, 16 times 11, 150, 54.75. YB equal 54.75. Okay? If you go back here and put YB equal 54.75, anybody can tell me what is the value of YA? I need answer. Guys, I need answer from this equation. YA plus 54.75 equal 52. What is the answer for YA? Thank you. Thank you. Negative 2.75. Anybody can tell me what is the meaning of negative? Negative means for YA, you assumed wrong direction. I assumed YA to up. No, it's wrong. This reaction must be down. How much? 2.75. So the correct direction for YA must be down. Please, before starting to draw, put the correct direction. XA is correct. YA should be down like this. YB is up. That's good. Please, before starting to draw axial force, shear force, bending moment, please put the correct direction of the reactions. I'm gonna draw vertical line, vertical line, vertical line, vertical line, vertical line, and I'm gonna draw 3 copies of this beam. This one for normal force diagram, shear force diagram, bending moment diagram. Okay, normal force diagram. Thank you, John. Normal force diagram. Which force? I will start from left. All of these diagrams, I'm gonna start from left to make it easy. Do you have any force at this left parallel to this beam? It's a very simple question, and the answer is very, 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 very simple. Do you have a force at this end A, at the end A, at the left end? Do you have a force parallel to this beam? Yes, I have. How much? 12. This force pulling or pushing the beam? Pulling. So it's tension. Tension means positive. So I have positive diagram. How much? 12. Positive. I am done. Very simple. And the answer is more simple. At the left, ask yourself one question. Do you have a force parallel to this beam? If you have, what is the value? If the value is 0, go ahead and write 0. If you have a value, okay, ask yourself another question. This force, the correct direction of this force, the correct direction of this force, pulling or pushing? Pulling means tension. Tension means positive. Any comment? Okay. Next diagram. Shear force diagram. I will go up if the force goes up. I will go down if the force goes down. But I have to start from left. Here is the left. What do you have at this left? Guys, please, one more time. Don't start to draw your diagram until you put the correct direction of the reaction, the correct direction. So what do you have at this side, your left? We have YA. How much? 2.75. Which direction? Down. So I will go down here by 2.75. your reaction is going down. Okay, that's fine. The reaction goes down, that's fine. So I will go down 2.75. This is the first time to talk about distributed load. Okay, nothing will not change. It's not a big change. Guys, I'm gonna move dashed. Why? Why dashed? Because I'm working inside distributed load. So I will walk normally, but dashed until you hit 16. 16 is going down, so I will go down dashed. More 16, you are at 2.75. I will go down 16 until you reach 18.75. Keep walking. Dashed. Keep walking. Dashed. Are you done with the distributed load? Yes. During distributed load, I will walk normal, but dashed. What you mean by normal? Yeah, I'm walking. I'm walking. If you have something, I will go up or down. If you don't have, keep walking until you reach the equivalent force, so I will go down. Keep walking. But the only difference, please, if you are inside distributed load, please walk dotted, not solid. Are you done? Yes. What is the value here? 18.75. What do you have at this location? We have another force, 20, going down. Please go down. More? Yes, more. I will go down 20 until I reach 38.75. Keep walking. Solid. Why solid? Because I don't have distributed load here. So keep walk normally until you reach YB, going up by 54.75. So I will go up by 54.75. I will go up until reach 16. Keep walking. Solid. Until the end, I have here vertical component 16, and you are at 16. Go down 16, I'm gonna reach to 0. Please, before finishing up the diagram, go back to the dashed line. From the first point and the last point of the dashed line, please draw a solid line. And this diagram can be called shear force diagram. No, Mitchell, for normal force, it's a different scenario, different story. For normal, if you have a value here, believe me, you will have another value on the other side. So your diagram will be constant. We don't need to reach to 0. Don't worry about this end. Okay? Normal force diagram is a different story. So the only difference in this diagram, this one for if you have uniform distributed load. For bending moment diagram, I'm gonna continue this diagram next meeting.